this video, we're going to be talking about set notation. Now, when I say notation, I just mean how we write sets. So set notation is about how to write sets. Now, it's important to understand how to write sets because sets involve collections of objects. And sometimes we might have collections of collections and things inside collections. And we need to be able to write what we mean and what we're talking about when we're dealing with more complex concepts involving sets. Hey everyone, real quick, I just want to mention that this video is a part of a whole course that I made. You can find a link to this entire course in the description below and make sure to click on that subscribe button. So we need some notation to make talking about sets easier. Let's consider an example here. Here's an example of a set. A equals 1, 2, 3. This is read, A is the set containing the elements 1, 2, and 3. We use curly braces here to enclose statements, to enclose elements of a set. Here's some more notation. We would say A is an element of, that symbol right there, it looks like an E, it's a little fancy, means is an element of the set A, B, C. The symbol here, again, is read is in or is an element of. Thus, we mean that A is an element of the set containing the letters A, B, and C. Note that this is a true statement. It would also be true to say that D is not in the set. And we would write that as D is not in the set A, B, C. Be warned, we write X is an A when we wish to express that one of the elements of the set A is X. For example, consider the set, and this one is going to look a little sophisticated here. Let's take a look at A equals the set 1B, a set XYZ, and the empty set, which is a set of nothing. This is a strange set, to be sure. It contains 4 elements. Specifically 4 elements. I know that's weird. It looks like it has 1, 2, 3, 4, 5, 6, maybe 7, 5, I don't know. It has 4 elements. The number 1, the letter B, the set XYZ, and the empty set. Which, by the way, we write the empty set as the collection of nothing. Is X in A? The answer is no. None of the 4 elements in A are the letter X. So we must conclude that X is not in A. Similarly, consider the set B, which equals, let's say, 1 and B. Even though the elements of B are elements of A, we cannot say that the set B is one of the elements of A. Therefore, B is not an element of A. Soon we'll see that technically B is a subset of A, which is a little different from being an element of A. We've described the sets by listing their elements. Sometimes this is hard to do, especially when there are a lot of elements in the set. Perhaps infinitely many. For instance, if we want A to be the set of all even natural numbers, we could write, for example, A equals 0, 2, 4, 6, ... But this is a little imprecise. Oops, there we go. That's a little imprecise here. A better way would be, and this is going to look a little sophisticated, but it's much more precise. A equals X in N such that there exists an n in the natural numbers such that x equals 2n. Let's look at this carefully. I know this is sophisticated, but we can unpack this. First, there are some new symbols to digest. N is the symbol usually used to denote the natural numbers. So this right here is a reference to the natural numbers, which we will take to be the set 0, 1, 2, 3, and so on. Next is the colon here. This is read such that. It literally means such that. It separates the elements that are in the set from the condition that the elements in the set must satisfy. So putting this all together, we would read the set as the set of all x in the natural numbers such that there exists some n in the natural numbers for which x is twice that number. In other words, the set of all natural numbers that are even. So this is the set of all numbers such that that number is even. In the next video, we will discuss how to use set builder notation to represent sets. I'll see you then.